Hi everyone. In a given population, let's consider the families that give birth to two childs, and let's suppose that the probability to get a male child equal the probability to get a female child in the first and the second birth. We would like to calculate the probability of the event A, according to which the two born childs are males. Then, the probability of the event B, according to which the older child would be a male. After that, the probability of the event C, which states that at least one of the two childs is a male. And finally, the probability of the event D, according to which the younger child would be a female. So for this we will note as M, the event according to which the born child is a male, and as F, the event according to which the born child is a female. And we trace the tree diagram of this experiment. So we would have in the first birth two possible outcomes, which are the event M and F. And for each of these two outcomes, we would have in the second birth two possible outcomes, which are the events M and F. Now, as we suppose that the probability to give birth to a male child equal the probability to give birth to a female child, then the probability to get the event M equals the probability to get the event F, which equals 0.5 in the first and the second birth. Furthermore, we notice from this tree diagram that the number of all possible outcomes of this experiment equal 4. Now among these four possible outcomes, we notice that there is only one path in which the two born childs are males, so we have one possible outcome for the event A to happen. So the probability of the event A, EA, which equals the number of possible outcomes for the event A, over the number of all possible outcomes, would be equal to 1 over 4, which equals 0.25. Now for the event B to happen, as the older child must be a male, we must have in the first birth the event M, for which we can have in the second birth either the event M or F, which mean that we have two possible cases that fits the event B. Therefore the probability of the event B, PB, equal the number of possible cases that fits the event B, which is 2, over the number of all possible cases, which is 4, which equals 0.5. Now for the event C, in which at least one of the two childs must be a male. We notice from our tree diagram that there are three paths that fit this event, which mean three possible outcomes that fit this event. Therefore the probability of the event C, PC, equals 3 over 4, which equals 0.75. Finally, for the event D, according to which the younger child is a female, to happen, we must have in the second birth the event F to happen, which mean that we have two possible outcomes that fits the event D. So the probability of the event D, PD, equals 2 over 4, which equals 0.5.